Hi, this is Simon Obstell and welcome to this revised second part of my tutorial on the theory of blend modes, which forms part of my overall Compositing School series. So we'll be looking at 4 new categories of blend mode. First, the simple modes in the dodge and burn group, bearing in mind we've already covered linear dodge in the first part of this tutorial. Secondly, the more advanced modes that derive from the overlay model. Then a set of modes that rely on hue, saturation and luminance rather than red, green and blue. And finally, we'll take a look at the group that's based on logical operators. So I've set up this composition with 2 viewers. One where at the bottom we can view Fusion's own version of the blend mode we're considering, and the other one at the top here where we can see the output of this custom tool here. Now I've set up the custom tool in such a way that we only need to enter an expression for the red channel and the other 2 channels will follow along. And I'll be using C1 to refer to this landscape background and C2 to refer to this lens flare foreground. And as you've probably seen, I've set up the text tool to give us an overlay here of the expression that we're entering at any one time. So first of all, let's look at linear burn. Now in part 1, we saw that linear dodge was a simple add operation. So that was C1 plus C2. You can see the result at the top here. And let's compare that with the Fusion version. Look at their linear dodge. You can see it's very similar. Now the difference with linear burn is that what we're going to do is we're going to subtract 1 from the background. So I'm going to open some brackets here, C1 minus 1, close brackets, plus C2. Let's just look at the Fusion version of that. So linear burn is looking like that. You can see the 2 look the same. So what we've done there, come back to our expression, is that we've driven all the pixels of the background well below 0. And then when we add the foreground to that, only the brightest pixels of the background are visible. So another way of thinking of what we're doing here is that we are doing to the background pixels what's known as applying an offset. Now that's a term you might be familiar with from color grading. So another way of looking at this process is that we're color correcting the background before adding the foreground to it. Now, as I'm sure you know, both dodge and burn are terms that derive from photographic printing processes. Dodging is what happens in the darkroom when you hold back the light to lighten an area of the print, and burning is the opposite. In other words, increasing the exposure to create a darkened area. Now, of course, in the darkroom, you can choose exactly how much dodging and burning you actually want. And I want to show you that this is something we can actually do ourselves. In this case, although the official version of linear burn subtracts a value of 1 from the background, there's no reason why we shouldn't modify the effect by only subtracting, for example, 0.5, or indeed 0.25, or indeed 0.75. And to my mind, all of those actually work pretty well and possibly better than the official version, if you will. And of course, instead of using a fixed default, we could actually attach a slider to that offset value. So I'm using N1 there. And if I adjust the N1 slider, you see we can go wherever we want with it. And it's created a really nice flexible blending tool. So it's almost like we're in the darkroom and deciding exactly the degree of burn that we're actually wanting here. Note that this is very different from simply adjusting the opacity of the blend, as it were. So if we come to the Fusion version here and we adjust the blend, you can see that it just goes sort of grey and not particularly interesting. Whereas by comparison, our custom version with our slider, it's actually keeping that kind of burn factor regardless of the value that we use. So we've got an advantage over normal blend modes where all you can do is adjust the opacity. And to my mind, in an ideal world, blend modes would be offered with just this kind of control that allowed us to manipulate the internal maths rather than simply the opacity. Anyway, let's move on more quickly and run through some of the others on our list. The next one I'm going to go with is color burn, and that looks like this. So 1 minus open brackets, 1 minus C1 close brackets divided by C2. So what we're doing is we're inverting the background, we're dividing it by the foreground, and then we're inverting it back again. So let's compare the Fusion version. This is color burn we're looking for. Again, looks the same. So now let's have a look at color dodge. So here we are. This is color dodge. Let's compare the Fusion version, color dodge. So what we've done with color dodge is we've inverted the foreground, and we're using that to divide the background. And for this lens flare composite, that's giving us a pretty nice result. So the next one I'm going to throw up is a fairly random one, and that's called exclusion. So let's have a look at that. Looks like this. Let's compare the Fusion version. That's all the way down here. Exclusion. Looks pretty odd. And what's actually happening is that the background pixels are being inverted wherever the foreground pixels are white. And I'll come back to exclusion right at the end of this episode and throw a little bit more light on it, hopefully. So the next one we're going to look at is overlay. So this is a new group of types of blend mode. So let's look at overlay. Looks like that. And let's compare the Fusion version as well. So there's Fusion's overlay at the bottom there. So the thing about the modes that are in the overlay group is that they use a threshold value to calculate how the blend operates. So looking at our expression, you can see that we've got this conditional that's looking at the values of the background, C1, and seeing whether or not they're above or below 0.5, in other words, mid-grey, and then applying a different effect to the result. Anything that's below the threshold is having a darkening operation applied, and all the other pixels, the ones that are above the threshold, above mid-grey, are getting a brightening operation, and hence we get this sort of bright and dark effect. And if you were paying attention to my first tutorial, you will probably notice that the darkening effect is a multiply operation and the brightening effect is a screen operation. Now, overlay and all the other blend modes in this group function principally as lighting effects, hence the fact that apart from overlay, they all have the word light in their name. So next up, let's look at soft light. Quite a complicated expression, but again, you can see it's using this conditional. Let's again compare the Fusion version, soft light. So unlike overlay, what's happening here is that we're not setting the threshold based on the background, we're setting it based on the foreground. So C2 is our lens flare foreground. Now you'll probably notice a difference between the Fusion version of soft light and the one we've created, and that's because I've shown you a pretty simple version, and I think Fusion is probably using a far more complicated version that looks like this. And you can see there now much closer. We haven't got quite such a pronounced darkening effect. And that's because we've got a kind of nested conditional here, which makes it all very, very complicated. And I don't think we need to try and get our heads around that at this point. Other than to note that the nested conditional tests for values that are below 0.25 or 25% and applies a different blending process when it encounters those. Now, I think this is a good moment to make a more general point. We've just seen an example of two different approaches to creating soft light, but you'll certainly notice that different applications handle these blend modes in different ways, which are not necessarily documented at all. In other words, there are some general principles, which are what I'm showing you here, but the exact execution is likely to differ. But I hope you've understood enough by now to realise that the differences are somewhat arbitrary, and it's not necessarily the case that one approach is superior to another. And indeed, if you're rolling your own blend modes, as we're doing here, you should by all means experiment with coming up with your own variations, rather than striving for a platonic ideal that doesn't necessarily exist or mean a great deal. So let's compare just one more from this group, and that's going to be hard light. So let's have a look at that. So that's our hard light. Let's compare Fusion's hard light down at the bottom. So this is quite a bit simpler than that horrendous soft light we were just looking at. But again, as with soft light, and indeed all the light versions apart from overlay, we're actually setting the threshold based on the foreground, not the background. And again, you can see it's darkening down the dark bits and brightening up the bright bits based on the foreground values. So one of the interesting things we could do with these modes is to set the values below the threshold to 0. So if I do that, we can isolate exactly what's happening with just the second part of that conditional. And if I swap that around and do the opposite, by entering 0 here instead, we can see what's happening with the other half of the conditional to all the pixels below that threshold value. So those two operations are completely distinct and are separated from each other by the threshold. So there are a handful of others in this group, including vivid light, linear light, and pin light. But there's no point in going into those here, since I'm sure you've got the overall idea by now. They all do this same darkening and brightening effect based on that threshold. So next, I'd like to look at 4 modes that rely on a very different sort of method to anything we've looked at so far. And the difference is that instead of calculating a result based on red, green, and blue pixels, we're going to be using hue, saturation, and luminance. And to do this, we need to switch into an alternative color space that allows us to access those values. And here in Fusion, I'm going to do that using the HLS color space option. So essentially what each of these new modes does is a simple substitution with no sums involved. In each case, they return the background image with one channel replaced by the corresponding channel from the foreground image, with the exception of color, which uses 2 of the foreground channels. Now, typically these modes are more commonly used to composite solid colors or gradients over the top of images, rather than to combine 2 images. And for that purpose, I've chosen a new background image, and for my foreground, I'm using this graphic of these 3 colored circles. And what actually happens with this blend mode is that we switch into the HLS color space. And here I'm doing it using the color space node. I've got it set to color and HLS. So I've used that here on my background, and I've got an instance of it on the circles. Obviously, I'm not running the Fusion version through that, only my custom tool version. And then at the other end, we convert back out of that. So I've got another color space here, and I'm converting from the HLS space back to RGB. So we're looking at the normal image. Now, as we go through, I'll continue to show you the Fusion equivalents, but only to point out that there's something a bit wrong. And I will also be showing you the Resolve equivalents, so you can see that we're actually on the right track with our custom versions. So the first blend mode we're going to look at is hue, and we can do that in our red expression here by typing R2, which will replace the hue of the background image with the hue of the foreground image. And let's also come over and switch the Fusion blend mode to the hue blend mode, this one here. And here for comparison is the Resolve version. So you'll see that these are relatively similar. And what's happened is that our background image has taken on the hue of the foreground image. So obviously we had black all around our circles, and that's why most of the image has now gone grayscale. And red actually, of course, has a hue value of 0, and that's why the red circle is not really visible, and that's just grey as well. So we've looked at swapping out the red channel, which is the hue. So let's switch that back to its original. Let's move on down to the green channel, which is the luminance. So I'll switch that to G2, and let's do that with the Fusion version and switch to luminosity. You can see already the difference between these two, quite considerable. What I'm actually going to do is swap these foreground and the background around so we can see this a little bit better. So Control T on that, Control T on that. And again, for comparison, here is the Resolve version. So just a reminder that because we've switched the inputs around, we're actually using the luminosity of the background image, as it were, to affect the circles graphic. So again, I'm sure you can see all the discrepancies, and I'm not really going to waste time speculating on what is causing them. So let's move on through. We've looked at the luminance, so that's the L of HLS. So let's switch this back to G1 and let's look at the saturation mode. So for that we need B2 for the blue. And again, let's come over and set this blend mode to saturation. Definitely something funky going on here. So let's again swap them around. Swap that around, swap that around. And let's compare the resolve version as well. So what this is doing is applying the saturation of the circles to our background image. So wherever our foreground image was black, we've got no saturation at all. But in each of the circles, which were all pretty saturated, we've got plenty of saturation, for example, in the water and the foliage and in the sky. Goodness knows what's going wrong with that Fusion version. But if we switch over to the Resolve version, we can confirm what it's meant to look like. Not identical to our custom version, but at least it's all making sense. So we've looked at swapping out each of the channels, but there is actually another mode where we swap two of the channels, and that's called color. So in this case, in addition to B2 for the blue, I'm going with R2 for the red. So we're substituting both hue and saturation. And then let's look at the Fusion version of color. So again, a very considerable difference, and here for comparison is the Resolve version. So lots of discrepancies overall, but this is not really the place to try and resolve them. So color is a very useful blend mode, especially for grading purposes. It has a big advantage over hue, where, if you will remember, our red circle had completely disappeared. Here we've got the full color information across the board. And if you use it with color gradients, you can get some really nice grading effects. So finally, let's take a look at the group of modes that use logical operators rather than simple arithmetic. And we're going to focus specifically on AND, OR, and exclusive OR. Now, when I first made this tutorial, you could still find these modes offered in Fusion, but they've since disappeared for probably quite good reasons. But I think the theory of them is still worth exploring, so let's have a look. Now, unlike arithmetical operators, logical operators can only return either a value of 0 or 1. Or in computer terms, they return either true or false. So in image processing terms, that should mean that anything that results in a value of 0 or false comes back as black, and anything that results in a value of 1 or true comes back as white. So to demonstrate, I've made this new setup. We've got our background image that's vignetted over black like that, and we'll also have this text object, so text over black. And here's our custom tool that we're going to be working with. Again, I've linked the blue and green to the red expression. So the logical AND operation works like this. We type C1 and C2. You notice that's the ampersand. And what that does is wherever both the foreground and the background pixels have a value of 0, we get 0, in other words black, and everything else returns a value of 1, in other words white. So in this case, where my text overlaps my image, my vignetted image, I'm getting white and everything else is black. And in terms of set theory, this is known as an intersection. So now let's compare OR. And all we need to do is swap the ampersand for this vertical line symbol like that. And what this means is that everything in both background and foreground that has a value of 0 is returned as white, and everything else is returned as black. So in this case, it means that both my image in the circle there and the text appear as white. Again, in set theory, this would be called a union. You can see why that is. We've kind of got a union of those two elements. So finally, let's look at exclusive OR, which is the interesting one. And that's usually abbreviated to XOR. So with this operation, if either the foreground or the background pixel is non-zero, but not both, it returns a value of 1, otherwise it returns 0. And I can create this operator by combining AND OR in this conditional expression. So if, open brackets, C1 and C2, comma, 0, comma, C1 or C2, close brackets. So in this case, both my circle and my text appear as white, but not where they intersect, and that's where they are black. And in terms of set theory, this is called a symmetric difference or a disjunctive union, because it's a union without the intersection. So there's obviously a problem with all of these operations, and that's inherent in the fact that they're logical operators rather than mathematical operators. So all we ever get is 0 or 1, and that means that we don't get any intermediate values. And if you look closely at our text, you can see that it's steppy. There are no grey values that can soften that off. So the thing is, although I've shown you the actual logical operations here, whenever you see these particular operations offered, they are more likely to be substitutes for other operations, and those operations get around this problem. And in fact, they're all quite simple, apart from one of them. So for example, for the AND operation, which if you remember was C1 and C2, which gave us this, we can instead use the multiply operation, which you're familiar with, C1 times C2. And now, obviously, our text edges are perfectly nice because we're using grayscale values there. And because the output allows for pixel values other than simply 0 and 1, we're actually getting the RGB values of our image. Similarly, if we want the OR operation, it's even simpler. So the OR operation looked like this. And if we want to do the clean version, we simply use add. And again, it's the same thing, but obviously we're getting the color of the image in this case. But what about the exclusive OR, the XOR operation? You might remember that I briefly touched on the mysterious exclusion blend mode earlier on, and that's actually what we need to use here. So if we remind ourselves what the logical version looks like, it looks like this. If, however, we use the exclusion blend mode, we get this. So it's the same thing, but with the color in there. And just to confirm our exclusion operation, let's compare it with the Fusion version. And they're the same. Now, for most practical purposes, you don't actually want this negative effect. So what is the purpose of the exclusion blend mode? Well, like these other logical operators, their typical purpose is for combining things like grayscale mattes rather than full color images. So the thinking behind calling them logical operators, when in fact they're just these arithmetical blend modes in disguise, is presumably so the user can form a better mental picture of how the result is going to work. Always assuming, of course, you know about these logical operations to start with. So that's about it for this time. We haven't yet talked about the operations that involve the alpha channel, and that's because it's a huge subject in itself, and we'll be coming on to that in part 3. So thanks very much for watching, and hope to see you again next time.